Hey everybody, tonight is the final video of section P4. This is the final section on these types of equations. Here's what we're going to study in tonight's video. Solving equations of four types. We have polynomial equations, which we'll solve by factoring. We'll have radical equations. We'll have rational exponents. And we'll have absolute value equations. And we'll solve each of these using some techniques that I'm sure you've had before. So let's get started. I've got several equations of several polynomial equations that we'll solve by factoring. Now, these are not quadratic. You notice these equations that I'm going to show you here have a degree greater than 2. We talked about solving quadratics last night, but look at this. The degree of this is 4. So how do you solve a polynomial equation? Well, the first thing we're going to do is we're going to talk about factoring. So this is not a quadratic, but if you look at it, this is a perfect square, x squared times x squared. And this has factors, 2 and 1. So what we can do is we can set up our parentheses just like we're going to factor this as if it were a quadratic. In other words, we're going to FOIL. We're going to take this x squared and x squared, and we're going to take this 2, and it'll be 2 and 1. And somehow we need to turn this outer and inner FOIL into -3, so that's 2x squared, and that's 1x squared. If we make them both negative, then we have a +2 and we have a -3x squared. Now again, this is called quadratic form, even though it is not a quadratic equation. And quadratic form is, this is always an even number, this is half of that number, and this is a constant. So if this were a 6, it could be a 3 and a constant. If this were an 8, this would be a 4 and a constant. And if it fits that pattern, then you can usually factor it, or that you possibly might be able to factor it. Now let's talk about the solutions here. As you know, you take each parenthesis and set it equal to 0. So what we have here then is x squared is equal to 1. And x is equal to, and remember, if it's x squared, it says there are going to be 2 roots. So don't forget plus or minus 1. And here, x squared is equal to 2. X is equal to plus or minus, take the square root of 2. So the 4 roots here, there are 4 answers, plus 1, minus 1, plus and minus radical 2. These are the 4 solutions for this particular equation, which is a polynomial equation in quadratic form. I'm going to slide that up a little now, and let's look at the second equation on my sheet. This one is also a quadratic equation, x cubed and x. You will notice this one can be solved. This tells you that there will be 3 solutions. And let's solve by using the greatest common factor. This is not a quadratic form, so we'll just remove the greatest common factor, which is 3x. And that will factor 3x into 3x cubed goes x squared times minus 3 equals 0. This is the GCF method of factoring. Not quadratic form, but just taking out the GCF. So 3x is one factor, and that equals 0. And x squared minus 3 equals 0 is the other one. This has one answer, x is equal to 0. And this right here, x squared means 2 answers, is equal to 3. And x is equal to plus or minus, always important when you take a square root, the square root of 3. Solutions for this problem are, there are 3 of them, 0, plus or minus the square root of 3. Finally, my third example of polynomial solved equations would be this one right here. And you will notice the first thing you see on this problem is that there are 4 terms. 1, 2, 3, 4. 4 terms. It does not have any quadratic form, nor is there a greatest common factor other than 2. Now, you can take a 2 out of everything if you want, but for our purposes today, I'm going to illustrate something called factoring by grouping. And this is about your best hope if you have 4 parts. So what we're going to do is we're going to remove the graded. We're going to just take a chance and group these guys together like this. Group the first 2, group the second 2. Now, how do you know when you're going to use factoring by grouping? Well, first of all, if there are 4 parts, factoring by grouping is a definite possibility. All right, let's take the greatest common factor of these first 2, and it would be 2x squared, and that would leave an x minus 3. And then the object of the game is to make the same factor fall out of the second set. So let's take out a greatest common factor of negative 6, and we have left x minus 3. So we have this times x minus 3, this times x minus 3. And I'm going to get my red pen so I can make this real apparent. Then you're going to take this factor and put them together in one set of parentheses. 2x squared minus 6 times x minus 3 equals 0. In other words, they're both multiplied times x minus 3. So we're just going to pull them together like this. And now we can solve. X, I'm going to do this one. Well, let's start here. 2x squared minus 6 is equal to 0. 2x squared is equal to 6. Divide that 2 out of there. You could have done it earlier. X squared is equal to 3. And x is equal to plus or minus, whenever you take the square root, be sure you put that, square root of 3. And the other one is x minus 3 is equal to 0. So x is equal to 3. So here are your solutions. 1, 2, 3. Okay, so that's one type of equation we're dealing with tonight. I'm looking at my time. I may have to spread this into 2 videos. These were polynomial equations solved by factoring. Okay? All right, the second thing we've got on our agenda for this evening would be radical equations. I'm going to get through these radical equations, and then I'll probably start another tape because I can't run over 15 minutes. All right, let's look at the rules for basic solution of radical equations. A radical, of course, is this little square root symbol. It can be a square root, a cube root, a fourth root, whatever. But these are all, and these examples that I'm fixing to give you are all square roots. Now, here's what you want to do. You want to isolate, I'm going to start some instructions right over here. Number 1, you want to isolate the radical. Isolate means to get it by itself. So let's isolate the radical. In other words, in this problem, we're going to say, let's put the square root of 2x plus 7 on the left where it is. And then let's move everything else, including the negative x. Let's move that over, x plus 2. Okay, so isolate the radical. Second step. Since this is a square root, we're going to square both sides. Now, if it were a cube, we would cube both sides, cube root. If it were a fourth root, we would raise both sides to the 4th power. But what I want to do is I want to square both sides. So I'm going to take this pen, and I'm going to indicate that I'm squaring that. And I'm also going to wrap parentheses around that and square that. Now, the left side is easy to square. 2x plus 7 equals. This squares as a binomial, and a lot of you are going to make this careless mistake here, so be really careful. This is x plus 2 times x plus 2, and you should know that pattern by heart, but I know some of you don't. X squared plus 4x plus 4. This is square the first, double the product, square the last. Now, once you've done that, notice you've gotten rid of all of the symbols. So now it becomes this. Set it equal to 0. X squared plus 2x minus 3 equals 0. And now that's a quadratic equation. So we have factoring x 3, 1 plus minus equals 0. And our two roots are x equals -3 and x is equal to +1. Okay? Second example, radical x plus 4 equals 3. All right, remember the rules from before. Isolate the radical. It's already isolated. Square both sides. Okay, that's going to be pretty easy. So when we square this, we're going to get x plus 4. And when we square 3, we're going to get 9. And so x should equal 5. One thing I say, you can't predict the number of solutions that you're going to have. So you just have to be careful. All right, that's a simple equation. I've got a much harder one on here, but I'm going to hold that off and use it maybe in a special exercise in class. Okay, I'm going to try to move to my third section before I run out of time. These are rational exponents. Rational means fraction. So look at this exponent. X plus 1 raised to the 2/3 power equals 4, and x plus 2 raised to the 3/4 power equals 27. These are two examples of problems or equations solved using rational exponents. Now, there's a lot of discussion as to the best way to do this. What I like to do is I like to bring both of these, I like to raise both sides by whatever power is necessary to clear this denominator. So this is a 3 in the bottom, so I'm going to cube both sides. Now when you do that, you're going to get x plus 1. You see this 3? It's going to knock out this 3. And so we're going to be left with x plus 1 squared equals, and take your calculators and raise 4 to the 3rd power, and you'll get 64. Okay, so what I did is I raised this to the 3rd power, which really just knocks out that denominator and leaves me with this, equals 4 to the 3rd, 4 cubed is 64. Now, go back to your study of solving quadratics and take the square root of both sides. X plus 1 equals plus or minus 8. And then subtract 1 and you will have, so either x is equal to 8 minus 1, which is 7, or x is equal to -8 minus 1, which is -9. And if you put both of those in, they should work for you. All right, I'm about to run out of my time, so what I'm going to do is I'm going to ask you to turn off your video for just a second and work this second example. And if you'll pause it for just a second, then we'll pick up in just a minute with you. Okay, we're back with this problem. Hopefully you've had a little time to look at it. Notice the denominator was 4, so we raised each side to the 4th power, which knocks out these 4s and leaves us with x plus 2 cubed equals this huge number, which I just got off my calculator. Then I've got to take the cube root of both sides. The cube root of this is 81, subtract 2, and x equals 79. So there you have it, 3 types of equations that you're going to have to deal with. I'm going to pick up on the 4th one in a second portion. So if you'll cut this one off and then look at the next one, there's the rest of it. I've got about 3 minutes left. So there'll be a second one. Thanks for listening.